4-1, which is prime factorization. So I want you to click that. Yours should come up. Mine's being funky. Should also be the first thing in your stream. Should look like this. Okay? Click on it so it'll come up. And when it comes up, your first slide should look like this. Okay? Is everybody here? Anybody that's not here?
Okay.
Hush. All right, the next slide, if you flip over, is our table of contents, okay? I am at the bottom of my table of contents. So I had to go onto the back to start today, okay? So on the back of your first page, if you're at the bottom, some of you may not be at the bottom, I'm not sure, you're gonna add 2 things for today, all right? The first thing is Unit 4, Numbers and Fractions. That's going to be on page 25. The second thing is 4-1, which is prime factorization. You need to make sure that you've got both of those things in your table of contents. All right, if you will turn to page 25, I'm going to flip and go on over, and I'm going to come back. On page 25, you need to write Unit 4, Numbers and Fractions. If you have a tab, you can add your tab so that it is, you can see it when you're looking at your journal. If you don't have a tab, that does not matter. Your pages are numbered at the front, so that's not that big of a deal, okay? But you do need to have, on page 25, Unit 4, Numbers and Fractions. Now, today's lesson, we're going to talk about finding common factors. And we're going to talk about the multiples of different numbers, okay? The factors you use to get 2 numbers. I do not want you to write this at the top of the page, okay? Because I have done that for you. At the top, your focus statement for today is, I can determine if a number is prime or composite and write the factors of a composite number, okay? So we have 2 parts to today's lesson. We're going to figure out if a number is prime or composite, and the composite numbers, we are going to figure out the prime numbers that make up that composite number. And that's page 25, and this is 26. Where are you? You got to do faster, son. All right, so the first part of this lesson is we've got to figure out if numbers are prime or composite, okay? So that's what we're going to do. So everybody should have this paper taped over here. But we need to talk about what does it mean to be prime or composite and what is a factor, okay? So you have probably talked about what factors are before, all right? You probably talked about that in 5th grade. Who remembers what a factor is? Does anybody remember? What is it?
Numbers you multiply by?
The numbers you multiply to get a number, okay? So let's think about it. Let me flip this over, and this is on your slide. 2 numbers that are multiplied together. Now, I'm going to write my examples up here, and I am going to write them kind of big just because I want you to be able to see them, okay? So, if I have 10 as an example, what can I multiply together to get 10?
5.
Let's start with 1. 1 times what? 1 times 10. And then 2, can I multiply 2 times anything?
5.
2 times 5. 3. 4. And I'm back at what? 5. So the factors of 10 are 1, 2, 5, and 10. I just kind of make a U to write them in order. Let's look at the number 5. What can I multiply to get 5? 1 times what? 1 times 5. Get a paper. Wait a minute, I'll bring one. 2 times, 3 times, 4 times, and I'm back at 5. So it's just 1 and 5. Those are my only factors of 5. All right, so let's think about those 2 numbers. I have 10 that I can multiply 1 and 10 and 2 and 5. And I have 5 that I can only multiply 1 times 5 to get 5, and that's it. So 1 is a composite number. 1 is a prime number. All right. Justin, what does this say right here? What kind of book is this?
Science.
No. Starts with a C.
So composition notebook.
Composition notebook. Okay. If your science or your science, math, social studies, whatever you have notes in that look like this, it is a composition notebook. What is it made of?
Paper.
A lot of paper, right? So it is composed of a lot of paper. If you compose a writing, you write a lot of words, right? If you combine ingredients for a cake, what do?
You mix everything together.
You put everything together. You mix everything together. Is it just one ingredient?
No.
No, it's multiple ingredients, okay? So a composite number, that prefix COM, means to put together. A composite number means for you to have more than one set of factors, okay? You have more than one set of factors. So which number up here would be composite? Would it be 10 or would it be 5? 10. Because I can multiply more than just 1 and 10, okay? So if it's not composite, 5 must be what? What's the other one? Prime, okay? And prime just means that you can only multiply 1 times the number to get that number, all right? And I'm going to put both of those definitions up here, and I am going to write our examples. So that you can see both of those right there. All right, who needs a highlighter? Does anybody need a highlighter?
What do we need to highlight for?
I'm just gonna tell you. Does anybody need a highlighter? If you need a highlighter, raise your hand. All right, I want you to highlight that 0 and 1 are neither. 0 and 1 are not prime. 0 nor 1 is composite, okay? It's not prime, it's not composite. All right, I'm going to give you a little piece that I want you to tape on the top left, and it's a list of numbers between 1 and 50, okay? Tape this on the top left. It's a list of numbers between 1 and 50. And we are going to figure out which numbers are prime and which numbers are composite. So, we're going to circle all of the prime numbers. We're going to mark out all of the ones that are composite, okay? 1, what did we just highlight about 1?
They're not composite.
It's not prime or composite, so I'm going to mark it out. All right? 2, what can I multiply to get 2?
Nothing.
1 times
Oh.
2. Anything else?
No.
So it's what?
Prime.
It's prime, so I'm going to circle it. 3, what can I multiply to get 3?
1 and 3.
1 and 3. Anything else?
No.
Nope. So it's prime. 4,
1 and 4 and 2 times 2.
1 and 4 and 2 times 2. So I'm going to mark it out because it's what? Composite. Now, what do we know about all even numbers after 2?
They're composite.
They're composite. How do we know they're composite?
Because you can times more than 1 times that number.
All even numbers after 2, you can multiply 2 times something else besides 1 to get that number. So I want you to go through and I want you to mark out all of your even numbers. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, and 50. All of those are even numbers. So we can multiply 2 times something to get those. So we know that those have to be composite. Now the list looks a little less intimidating, doesn't it?
Yeah.
All right, 5. What can I multiply to get 5?
1 and 5.
1 and 5, and that's it. So it's prime. Now let's think about multiples of 5, okay? 5, 10, we've already marked 10 out. 15, can I multiply something by
3 times 5.
3 times 5? So everything that ends in a 0 or a 5 should be what?
Prime or composite?
Composite. We should mark those out. We've already marked out the zeros because they're even, but all of these with the 5, we should what?
Mark out.
Mark out because they're all composite. Seven, is it prime or composite? Prime.
Basically, any number that can't be doubled by 2 is composite. So, like,
Okay, so if it was even, we marked it out. Okay, So now, multiples of 3. Let's think about multiples of 3. We've already marked out all the even multiples of 3. Okay? So 3, 6, 9. What can you multiply 3 times to get 9? 3. So we can mark it out. 12 is even. 15 is a multiple of 5. 18 is even. 21. 3 times what? 21. 7. 24 is even. What about 27? 3 times what?
3 times 7. No. Yeah.
8.
Yeah.
I don't know.
3 times what is 27?
12. No. 7.
9. 3 times 9. 30. We've already marked it out. 33. 3 times what? 11. 36 is already marked out. 39 is 3 times what? If 3 times 12 is 36, 3 times what is 39? 13. 39. 42 we've already marked out. 45 we've already marked out. 48 we've already marked out. And that's all the multiples of 3.
Let's put multiples of other numbers.
Okay. 7. Do we have any multiples of 7? Which one? 11. Is that a multiple of 7?
Yeah.
Count by 7s.
Oh,
It's
no.
14.
14.
It's already marked out.
Already marked out. What comes next?
21.
21. Already gone.
49.
49 is 7 times 7. Anything else?
I don't think so.
Nope. All right, 11. What can I multiply to get 11? 1 times 11. 13.
1 times 13.
17.
1 times 17.
19.
You can times that. No, I can't. I was thinking of 18.
19.
1 times 19.
23.
1 times 23.
29.
1 times. Nope. Yeah.
31.
31. I don't think you can times anything but 1.
37.
1 times 47.
41.
Yeah. I think we just circle everything.
Yep, the rest of them are prime. It wasn't as hard as you thought it was going to be, was it?
No.
No.
Wait, 11 is 1?
11 is prime. Yes.
11.
Okay, now we're going to talk about something that we can do with the composite numbers. The composite numbers, we can break them down into prime numbers, okay? And that is called prime factorization. So, prime factorization is factoring out all the prime numbers that you can multiply to get a composite number, okay? So you might want to write this over here on the right. It's where you factor out all of the prime numbers that make up a composite number. So, Ava, pick a composite number from up here that we marked out.
25.
25. All right, Ava picks 25. All right, I've put the steps over here, but I'm going to show you, okay? We put the number at the top of our tree. Okay, we're going to call this our tree. Then we're going to make 2 branches. Looks like an upside down V, all right? What times what besides 1 will give us 25?
5 times 5.
5 times 5. Now, step 3 tells us to determine if those are prime or composite. Is 5 prime or composite? If it's prime, we what?
Circle it.
Circle it. Both of those are prime, so we're done. So we have 5 times 5 is 25. Is that true?
Yep.
Yes. Now I can write this another way. Since I have 2 5s, I can write it as an exponent. 5 squared because I have 2 5s, right? Give me a number higher than 25 that's composite, Dustin.
38.
38. What times what gives me 38? We know it's even, so we know we can multiply by what? 2. So it's 2 times what? 19. 2, is that prime or composite?
2 is prime.
19 is,
Prime.
so my prime factorization is just 2 times 19. I want to do one more, okay?
How about 7?
Nope, that's prime.
Oh, yeah, okay.
It's got to be composite.
46.
Let's do 48. So I want you to put 48 at the top. Now, there are several different things that you can multiply to get 48. And you can do it however you want to do it. We can pick whichever numbers you want to begin with. We're still going to get the same prime numbers, okay? So, Justin, tell me something I can multiply together to get 48.
7 and 7.
That's 49. Ty,
24.
24 times
2.
24 times 2. We could have done 4 times 12, 6 times 8. It doesn't matter, okay? Now, 2, is that prime or composite? Prime. So I'm going to circle it. 24, prime or composite?
Composite.
So what times what gives me 24?
12 times 2.
12 times 2. 2, is that prime or composite?
Prime.
So I'm going to circle it. 12,
That's composite.
composite. What times what is 12?
6.
6 times 2. 2 is prime. 6 is
Composite.
composite. What times what is 6?
3.
3 times 2. 2 times 3. So we have 2 times 2 times 2 times 2 times 3. So let's check behind ourselves. 2 times 2 is
2 times 2 is 4.
4. 4 times 2 is
8.
8. 8 times 2 is
16.
16. 16 times 3 is
48.
48. So is that right? Yes. Now I can write this as an exponent. How many 2's do I have?
4.
I have 2 to the 4th power times 3. Justin didn't like that one because it kept going like the Energizer Bunny, didn't it? Mm-hmm. Don't forget to tape your prime numbers over there.